The next library that we're going to take a look at for Hadoop is called Pig. Pig is an ETL library for Hadoop, and it generates MapReduce jobs just like Hive does. It's a higher level abstraction, and it was developed at Yahoo. Now, ETL is a different kind of process than a generic query process, and we're going to be talking about that in this section quite extensively. ETL stands for extract, transform, and load. The Pig library uses the Pig Latin language, so these people at Yahoo had a sense of humor, and it uses commands like oink and grunt, really. So let's smile and start working with Pig and Pig Latin. So when should you use Pig versus Hive or MapReduce? When you have processes that are ETL-like. If you come out of the relational world, you might have used ETL tools for SQL Server, for example, such as SSIS, SQL Server Integration Services, which allow you to create ETL data transformation workflows. Other implementations of these kind of tools in the relational world are things like Informatica, and Oracle has a set of ETL tools. So the idea is when you have ETL-like jobs or tasks, you want to use Pig as an abstraction language because it was specifically written to make those kinds of processes easier. So examples are transform data. For example, you might have a set of text data coming in, a big blob of text, and you might want to split it into words, so our sort of classic word count. You'll see, I think, in our example, that the implementation of word count is actually more elegant and simpler using Pig than using Hive. To clean data, it's really common in big data scenarios that you're bringing in behavioral data and it might have junk or data that is incorrect, improper, or that you don't care about. For example, you might be collecting data from sensors and maybe there was a blip or an outage or there's some incorrect data. So you want to look for data that is incomplete and then you want to discard it. To process data. In big data scenarios, the volumes of data can be exponentially more than you're used to dealing with. So using the Pig language against HDFS and Hadoop platform really makes a lot of sense when you've got a tremendous volume of data and maybe you just want to aggregate it up. An example might be you might get location data from all of your customers worldwide as they go through your stores or go through a certain section of the offering that you have. And maybe you only want the data from a certain time period, from time A to time B, and the rest of the data you don't need. So it's a great use of resources to dump all that data into a Hadoop cluster and then use Pig to filter and process that data. So how does Pig work? Generally, there's an ETL process and flow that looks something like this, and the all capitalized words are keywords in the Pig Latin language. So you're going to load some file or files, and again, just like with Hive, you can load from a file system, a standard file system, a cloud-based file system, or you can load from HDFS. And then you're going to perform some operations, and you're going to find, as you work with Pig, that there's a rich set of functions that are associated with the Pig Latin language. So functions that you're used to and you're going to find very useful, like filter, join, group by, for each. I want to call your attention to the generate function because this is really commonly used in ETL Pig workflows. Generate allows you to do some process on the intermediate data and then to generate some new values. So it's a really common programming paradigm in Pig ETL process flows. And then you'll usually take the output and either dump it to the screen for testing so you can look at it and see if your process is correct, or if you're satisfied with it, you'll store it to a new file location. And as with other processes on Hadoop, you can choose to store your output as new files into the HDFS file system, or you can store it into some other file system which can be local or cloud-based. Another consideration if you're working with HDFS is to remember that HDFS files are immutable. So if you are transforming and you're creating new results or really making any change whatsoever, you're going to have to create new HDFS files. So sometimes as part of the process, you'll move or put the old HDFS information back into a less redundant file storage. That can be part of a workflow. For example, on Amazon, sometimes I'll move the original HDFS back into S3 because the storage is cheaper. You might remember that HDFS by default is triple redundant. And so if you've already processed those files, it's a real common workload that you don't need to keep those in HDFS anymore, the original files. Maybe the results will stay in there, or maybe they'll go back, in my case, into S3 as well.